We all know that iron gets rusted in the presence of air and moisture. So, galvanized pipes are used to prevent rusting. And as you know, galvanized pipes are pipes where iron is coated with a layer of zinc metal. How and why does zinc prevent iron from getting rusted? Let's find out.
Welcome everyone. I am Devabrata Goswami and you are watching Chemistry 11. Today we will discuss an interesting concept, that is electrode potential. So let's get right down to today's agenda.
In today's session, we will discuss direct and indirect redox reactions. We will also understand the meaning of electrode potential and standard electrode potential. We will then apply the concept of electrode potential to calculate the electromotive force EMF of the cell. And then we will head to the exam decoded section to give you a perspective on the kind of questions asked in exams.
I believe you are familiar with the term redox reaction. Nonetheless, here is a definition for you. In a redox reaction, oxidation and reduction reactions occur simultaneously.
Take a beaker with copper sulfate solution, dip a thermometer in it, and then add zinc in the solution and observe for some time. After a while, you will observe that the blue color of copper sulfate solution has faded and a reddish-brown precipitate has settled at the bottom of a beaker. This precipitate is copper. We note the temperature once again.
Now, let's get to the bottom of this reaction and figure out what actually happened.
In this reaction, zinc loses 2 electrons and is oxidized to form zinc ions. At the same time, copper ions in the solution gain the 2 electrons which are lost and reduce them to form a copper atom. This is an example of a redox reaction.
An important point to note here is that both the oxidation and reduction reactions occur in the same vessel. This type of reaction is called a direct redox reaction. When you take the temperature readings during the reaction, you will find that the final temperature is more than the initial temperature. This rise in temperature is because the direct transfer of electrons has changed some chemical energy to heat energy. In order to prevent the loss of this energy in the form of heat, indirect redox reactions are used. Here, the oxidation and reduction reactions take place in different vessels. The transfer of electrons takes place indirectly through conducting wires. So, the chemical energy is not lost as heat energy and is converted to electrical energy. Does this concept seem familiar? Yes, our battery cells work on the same principle. In an indirect redox reaction, the device which converts chemical energy into electrical energy is called an electrochemical cell. Each part of the electrochemical cell is called a half cell. So, the half in which oxidation takes place is called an oxidation half cell, and similarly, the other half in which reduction takes place is known as reduction half cell. The metal rods seen in the apparatus are known as electrodes and they emit, control and receive electricity. The electrode at which oxidation occurs is known as the anode. The anode is negatively charged. And the electrode at which
reduction takes place is called cathode. The cathode is positively charged. So one can say that in a redox reaction, the transfer of electrons takes place from anode to cathode, and the flow of current is in the opposite direction, that is from cathode to anode.
Now you need to know about the salt bridge. In the electrochemical cell, the electrical circuit is incomplete without a salt bridge. So what is a salt bridge?
A salt bridge is a U-shaped tube filled with a solution of an inert electrolyte like potassium chloride or potassium nitrate, which does not interfere in the redox reaction. The ions are set in a gel or agar-agar. The salt bridge completes the electrical circuit and maintains the electrical neutrality of the two half cells.
But now it's time for us to cross the bridge to our next segment. Yes, I mean to say we will take a short break, but I'll leave you with something to keep the electrical circuits in your brain buzzing. Tell me, what kind of electrolytes are used in a salt bridge? Finding it difficult to answer the question? Keep thinking. Welcome back. I am Deobrata Goswami and you are watching Chemistry. I had asked you a question before the break. What kind of electrolytes are used in a salt bridge? And now I will tell you the answer. Inert electrolytes are used in a salt bridge. These electrolytes do not undergo chemical decomposition in preference to a cell reaction. For example, potassium chloride. At this point, I would like to take in a question posted on our website www.topperlearning.com. The question is, why does oxidation reaction takes place at the anode and reduction takes place at the cathode? Well, the answer is simple. It is because of the difference in electrode potential. Now, what is electrode potential? Let us find out.
A strip of metal M is in contact with the solution of its own ions, Mn+. There are two possibilities here. The first is that the metal atoms may lose electrons to form Mn+ ions in solution. In doing so, the metal develops a negative charge because of the electrons which are released. At the same time, the solution develops a positive charge. This process would continue till a state of equilibrium is reached. The second possibility is that the metal ions in the solution may gain electrons from the strip and get reduced to metal atoms and get deposited on the strip. This leads to the development of a positive charge on the metal strip and a negative charge in the solution. Again, a state of equilibrium would be reached eventually. Note that in both the cases, equilibrium leads to separation of charges, resulting in a potential difference being developed between the metal strip and its solution. This electrical potential difference, which is developed between the metal and its solution, is called electrode potential.
Let us understand electrode potential more clearly. Electrode potential is the measure of the tendency of an electrode to gain or lose electrons. And when the concentrations of all the species involved in a half cell is unity, then the electrode potential is known as standard electrode potential. There are two types of electrode potentials, oxidation potential and reduction potential.
Oxidation potential is the tendency of an electrode to lose electrons or to get oxidized, and reduction potential is the tendency of an electrode to gain electrons or to get reduced.
So it is evident that both the types of electrode potentials are opposite of each other. By the present convention, the electrode potentials in an electrochemical cell are represented as reduction potential. Now, in an electrochemical cell, the two half cells have different reduction potentials. That means they have different tendencies to gain or lose electrons. So, the electrode with a higher reduction potential will have a higher tendency to gain electrons. It will undergo a reduction reaction, resulting it to form the cathode. Now, what happens to the electrode with a lower reduction potential?
Lower electrode potential means higher tendency to lose electrons. This indicates that an oxidation reaction will take place, making it the anode. Now, due to difference in electrode potentials, there will be a flow of electrons from anode to cathode, and the current will flow in the opposite direction. The difference between the electrode potentials of the two electrodes in an electrochemical cell is called EMF, or the cell potential. Please note that it is the driving force for the cell reaction and is measured in volts.
Now, let's take a call from one of our young students.
Hello sir, my name is Ankur. My question is, can we calculate the EMF of a cell using reduction potential values?
Thank you for the question, and the answer is yes. We can calculate the EMF of a cell using reduction potential values.
EMF is measured as the difference between the reduction potential of the reduction half cell, that is the cathode, and the reduction potential of the oxidation half cell, or the anode.
Let us understand EMF better with the help of an example.
An electrochemical cell has been constructed with copper dipped in copper sulfate solution and zinc dipped in zinc sulfate solution, and both the electrodes are connected with wires. Here, the reduction potential of zinc is equal to minus 0.76 volts, and the reduction potential of copper is 0.34 volts. Since the reduction potential of copper is higher than zinc, you will find that copper will be reduced and zinc will be oxidized. Therefore, zinc acts as an anode and copper acts as a cathode. Now, look at the equations carefully. EMF is the reduction potential of cathode minus the reduction potential of anode. So, here it is equal to reduction potential of copper minus zinc, which comes out to be 1.10 volts.
So you saw that by comparing the reduction potential values of the two electrodes of an electrochemical cell, the anode and cathode can be identified. Similarly, the EMF for a cell can be calculated. I am quite sure all of you know what galvanization is. For those of you who don't know, galvanization involves coating of zinc on iron objects to prevent them from rusting. Why zinc? Well, zinc has a reduction potential of minus 0.76 volts, which is lower than the reduction potential of iron, that is minus 0.44 volts. So, when the oxidation reaction takes place, it always is zinc which gets oxidized and prevents iron from getting rusted. Enough for a day, isn't it? I hope electrode potential is now clear to you. But if you still have some doubts, you can log on to www.topperlearning.com. Take a short break. I'll be right back with exam Decoded. Welcome back. I am Devabrata Goswami and you are watching Chemistry 11. Well, I know you are all waiting for exam Decoded. But before we address exams, let's do a quick recap.
Today, we learned that in a direct redox reaction, reduction and oxidation occur in the same vessel, while in an indirect redox reaction, the reduction and oxidation occur in different vessels. Electrode potential can be stated as the measure of the tendency of an electrode to gain or lose electrons. It is of two types: oxidation potential and reduction potential. The difference between the electrode potentials of the two electrodes in the electrochemical cell is called EMF or the cell potential. EMF is measured as the difference between the reduction potential of cathode and the reduction potential of the anode.
Well, I hope you are ready because we are going to test your potential in exam Decoded. Welcome to exam Decoded. Today we discuss the electrode potential and now it's time to see how much you have learned. Yes, it's the rapid fire round. Let me quickly take you through the rules. I will ask you 5 questions and you will have 5 seconds to answer each question. Here comes the first one. In an electrochemical cell, the oxidation reaction takes place at the anode. True or false? This is an easy question, so I expect all of you to know the answer. The answer is true. In an electrochemical cell, the oxidation reaction does take place at the anode. Now the next one. Reduction potential measures the tendency of an electrode to lose electrons. True or false? This is again quite easy. The answer is false. The third question. When zinc is added to copper sulfate solution, copper is precipitated. This shows that A. Zinc is reduced, B. Copper sulfate is hydrolyzed, C. Copper ion is reduced, D. Sulfate ion is reduced. The answer is C. Copper ion is reduced. I rate this question's difficulty level as average. The fourth question. In an indirect redox reaction, chemical energy is converted into A. Heat energy, B. Electrical energy, C. Mechanical energy, D. Potential energy. And the answer is B. Electrical energy. The last question. Which of the following have the greatest tendency to reduce themselves if the reduction potential of P, Q, R and S are 1.81 volt, 1.78 volt, 1.51 volt and minus 0.83 volt respectively? A, P, B, Q, C, R, E, S. This is a difficult question. The answer in this case is P, since it has the highest value of reduction potential. I am sure you knew the answers to most of the questions. Well, if you got 5 on 5, then you are a high flyer. If you got 3 or 4 on 5, then you are an achiever. But if you got less than 3, then you need to work hard. But don't worry, help is at hand. Log on to www.topperlearning.com to clarify your doubts and emerge a winner. This episode belongs to the chapter Redox Reactions and has a weightage of 3 marks, which makes it important. You can expect short answer questions for 2 or 3 marks related to electrode potential, standard electrode potential and calculation of EMF. These questions typically test numerical and conceptual ability. Now comes the part where I tell you how a question from the topic taught should be answered. So get out your pen and paper and jot down the answer. Let's take a typical question. Can a solution of copper sulfate be stored in a vessel made of nickel? Given the reduction potential of nickel is equal to minus 0.25 volts and copper is equal to 0.34 volts. Identify the cathode and anode in the electrochemical cell and find its EMF. I rate this question as average. If this comes for 3 marks, here is how you must answer it. Take a look. The first step here is to identify the anode and cathode. For that, you need to compare the values of reduction potentials which are given in the question. Since the reduction potential of copper is more than nickel, copper will form the cathode and nickel will form the anode. Writing this will give you a mark. The next step is to write the redox reaction. In the redox reaction, nickel atoms from the vessel oxidize to form nickel ions, and copper ions from the solution deposit as copper atoms. This implies that copper sulfate reacts with nickel vessel. Thus, it cannot be stored. Writing this will fetch you another mark. Now for the last step. The last step is to calculate the EMF of the cell. EMF is equal to the reduction potential of cathode minus the reduction potential of anode. Writing the correct formula will fetch you half a mark. Substituting the values of reduction potentials of nickel and copper, we get the value of EMF as plus 0.59 volt. This value will fetch you the last half mark. Good going, I must say. Now for some expert views and tips to help you max your preparation.
While preparing the topic electrode potential from the chapter Redox reaction, a student should basically concentrate on the definition of electrode potential, that is, the tendency to lose or gain electron. He should also prepare different types of electrode potential, namely oxidation potential and reduction potential. The student should also study how to measure standard electrode potential using SHE or NHE. Students should do this topic well because this is in continuation with the chapter Electrochemistry in class 12, which is very important. In this class, the student can basically focus on reasoning questions like why copper sulfate solution should not be stored in a zinc container.
Thank you for your valuable tips. With this, we come to the end of the show. But before I bid you adieu, here is a question to keep you thinking till we meet again. Why is it that we are always advised to have fresh fruit juices? I will see you again with another episode on chemistry. Keep thinking.